Here. Okay, record now.
Thank you. Thank you.
All right. So you're going to hit second ln, call it the e. And you're going to, it's 1.04 times 0, but you know, that's just going to be 0. So that's just 1, and then times 60 to 60. Or if you do it all in one shot, 60 times second ln 1.04 times 0, still get 60.
Okay.
So that's all I did, that one. So that's your initial value. Now, find number of bacteria after 4.5 hours. That's just going to be P of 4.5. So it'll be 60 times E 1.04 times 4.5. And again, we'll go back to the calculator. 60 times E 1.04 times 4.5. So you get that. So much more bacteria.
Oh, okay. Got it.
6,400. We'll round to the nearest whole number.
Yeah, so 6,466. Awesome.
Okay. Then find the rate of growth of bacteria after 4.5 hours. So find the rate of growth, that's to be a derivative. So you want this. Now, and the units will be bacteria per hour, because it's a slope, right? Because you're doing this, you know, the change y or change in x, the slope, and our y is the population, and our x is the time. And at times in hours, then the population is bacteria. Because you know it's written like y equals 60 times e 1.04 x. You can write like that if you so desire. X is always input, y is always the output. That's how we know this. So then we're gonna let the calculator do the derivative for us. You can do it by hand, it's not too hard, but let the calculator do it for us. Actually, to get the derivative is easy to do by hand, but to compute the numerical value, you need a calculator. So here's what we do.
How do you get the derivative?
I'll show you, real easy. So you could locate it two ways. It's up to you what way you want. I'll write down here. You could hit math, then option 8, or you could hit alpha, window, option 3. So if I hit math, option 8, it's right there. Or if I hit alpha, trace, option 3, it's called end deriv. It's called the end deriv feature. So here's what you do. You put in x right here. You put in the function 60 times second ln 1.04 x. X is right below mode. And x equals, you want to evaluate it at 4.5, so put 4.5.
Wait, how'd you do that? Oh, you did second.
It's right below mode. It's right below mode, x.
Okay. 60 times. Okay. Got it. And so that's the answer for that?
Yep. It'll be 6,724.
Let me write that down fully.
Or round to nearest whole number, 6,725 bacteria per hour.
Cool.
Keep moving.
That equals 6,724. Cool.
Okay. Then, yeah, so that's what, so probably the two are showing you ways you can find the derivative in the calc, but I mean the online, but we need to do it obviously in the calculator. And all the population reached 60,000 bacteria. Now, I'm not sure if your tutor was showing you Desmos. Is that what he was using?
I know Desmos. We used that a lot in stats last year. We used. Let me get it up. Symbol.
Okay. But anyway, we have to use a calculator, right? So when
Yeah.
population was 6,000 bacteria, so you want Y to be 60,000. So that's what has to happen. You need those two things to equal each other.
Okay.
So what we're gonna do, we're gonna go hit Y equals Y1.
Wait, where's Y equals?
Top left corner.
Oh, that's right. Yeah.
Y1 will do that.
Wait, would it be second Y equals or just Y
No,
equals?
Y equals.
Oh, okay.
So I'll show you.
Oh, I got it. Yeah.
You go to Y equals. Now, you see where it says plot 1, plot 2, plot 3. You're not going to
Yeah.
use that. That's for scatter plots. That's what you did in stats last year.
Right.
If it's turned on, you need to turn them off. Are any of those highlighted right now? Plot 1, plot 2, plot 3?
No.
You're good. Yeah, if they're highlighted, then what's happening is that means there's a scatter plot and it's going to probably give you an error if the window you're using does not fit. So we're going to put 60,000 right here. And 60 times E 1.04. And we use X instead of T.
E 4X. Okay.
Now, we hit graph. You're probably not going to see much of anything. The reason why
Oh, there it is.
is if you hit window, what do you see when you hit window?
Oh, it just did a syntax error after seeing it.
You make sure you typed it incorrectly. Go back to Y equals.
Y equals, so I have 60,000 and then for Y1, and then Y2 is 60 times e to the 1.04x.
Okay. And when you hit graph, you got a syntax here?
Yeah, so I got the graph and everything, and then it just does a syntax error right after.
What does it say? Is that can
Just
you
a syntax error.
okay, can you
Yep.
go back to y equals and then type in
So that's the Y equals.
that's weird.
And then
Okay, then
I'll
now
do graph.
hit graph. Okay, just hit graph. Okay, go back to y equals one more time. Okay. Huh.
It's weird
Oh,
because I
oh,
don't
oh,
have
go
any.
all the way. Okay. Oh, you must have something else going on. Go all the way down. Do you see like other things typed in for like Y7, Y8,
I
Y9?
do, yeah, Y8.
Yeah, that's probably why. There's probably something else going on there. That's why there's a
All right,
little bit
yeah,
of delay
that's
because it's trying to go through all the equations. I'm like, wait one sec, what is this? You know?
for Y6 on mine, it doesn't show a dash, it shows
Don't
a
worry about
0.
it. It's being stupid.
Okay.
It might have been something you did a long time. Don't worry about it. It's not a big deal.
All right, so graph.
Yeah, you shouldn't see the error anymore now.
Awesome. I think it's,
Now,
yeah.
the problem is we don't see y equals 60,000 because it's such a big number.
Mhm.
We have to go to window and we have to adjust the window so we can see 60,000.
Okay.
So what I'm going to do is I'm going to go all the way down to y min. I'll make y min 0. I'll make y max 100,000. I'll make y scale 10,000. Your x, could be really whatever. I mean, maybe you do like -10 and 10 and 1. That's kind of like standard. That doesn't really matter so much, but it's the y that matters because I have to be able to see 60,000.
-10. Yeah. Cool.
Yeah, so, okay.
Now go to graph.
Now go hit graph, you should be able to see it. You see that?
Yep.
Okay, now you gotta know where they touch. To figure out where they touch, you hit second, trace. You can see why, Desmos is so much easier, but we have to go through the brute force here. Second, trace, intersect.
Where's Trace again?
It's right next to graph. Right next to graph.
Thanks. Oh, I see it.
And this will be option 5. And
Intersect.
yeah, and after you do that, just hit enter 3 times. It should give you the x coordinate where they touch.
Yep.
You have 6.64?
Yep.
That's your answer. So it happens after 6.64 hours. Yeah, so that's when the population will reach that much.
And how do I show my work, I guess?
I would just write this and then do a quick sketch of the graph and just show the point of intersection. That's all.
And so for the point, it's 6.64 and 6, right? And y is 6,000. Is that right?
Was that?
Is y 6,000?
So 60,000.
60,000. Thank you.
Okay.
Cool.
Now let's look at 7. Simplify the function. So you could actually break it up as several logs. So generally speaking, if you have something like this here,
Mhm. Oh yeah, this one was tough. I remember.
so generally speaking, let's say you have something like this here. Then you can write as log A plus log b to the n power minus log c to the n power. So log A plus n times log b minus n times log c. So that's how we're going to break this apart. So
Actually,
the
can I get? Oh, sorry. Can I get something really quick?
go yeah, go ahead.
Yeah, give me 1 sec.
Okay. So the A is like x plus 2.
Are these the rules? Some of the rules?
Yeah, I'm using log properties, right?
Okay.
That's like b to the n power. That's like c to the n power. So you could just say this. Natural log of x plus 2. You're actually not really simplifying, you're actually expanding it. So it's kind of misleading, but 3 times natural log of 2x plus 1 minus 2 times natural log of x. So that's what f of x equals all that junk. So I'm decomposing this. Well, not decomposing, I'm like breaking it down.
Cool.
Okay. So now we want to do the derivative.
Mhm.
So you do 1 over. So we have natural log of x. So the derivative is just 1 over x. In this case, it's 1 over x plus 2.
Wait, write this out. So that would be the answer.
Yep. Because by breaking it down, you can easily do the derivative of each log separately. And the log of whatever is 1 over whatever. But if it's a chain rule, the second one involved the chain rule because 2x plus 1, so I multiplied by 2.
Okay.
Yeah.
Cool.
So yeah, it was good that one. So okay, so that's the rest of the worksheet.
Oh, is that the derivative?
Yeah, just hit it.
Oh, I got something completely different with the other two there, but yeah,
What
this
did
seems
you,
like
did you get?
uh log.
Sorry.
X.
There should be no log. Oops. Sorry. There should be no log here. My bad.
Oh, okay.
Yeah, because I already did that derivative.
Oh, so now I have to derive it more, right? After.
No, that's done. I mean, there's nothing more to do. I mean, you could simplify if you want. You can do 3 times 2 is 6. It's up to you.
Okay.
Well, what did you guys get?
1 over x plus 2. Oh, plus 3 times 2 over 2x plus 1, which is minus 2x, 2 over x.
Wait, I think I know what he did. Does he have this?
Yeah, we had that, and then we split it up.
And then you did the derivative of all that junk.
Yeah, and it
Yeah,
just didn't really make all the. It didn't make any sense.
I would not do that. So the things that yes, you can do, like the derivative ln of whatever is 1 over whatever. So if you have 1 over all that junk, and then you got to take the derivative of all that junk using a chain rule. The problem is that doing the derivative of that is a pain in the ass. It's just too much.
Yeah, I could tell.
What I do is I use a log property. That's why I said simplify the function. How do you guys simplify it? Like, how do you guys do part A then? That's what, and now I'm curious. How do you do part A?
Yeah. So we start with log of x of y equals log of x minus log of y. And then that turned into x plus 2 in parentheses, and then another parentheses, 2x plus 2. Is that 2 plus t? I can't really read my writing.
Yeah, that just seems kind of crazy.
Yeah, it was just really confusing. So I was like, yeah, let's do it with you because you'll probably find a better way to do it.
That's kind of how you want to do it. It's actually called logarithmic differentiation, where well, actually no, logarithmic, that's not something else I'm thinking of. That's kind of just much easier.
Yeah, but this seems a lot easier though. What you did. So thank you. Yeah, that really helps a lot.
So all right, cool.
Can we go over some more derivatives from last week too?
Sure.
Like some more extra problems, because I think I might I didn't get the quiz back, but I needed 8 out of 10, and usually I don't do well in these quizzes, so I kind of want to just keep going on it.
So what kind of derivatives exactly do you want to do?
Wait, actually, can we do one more problem or one more number from the homework? Sorry.
Oh, sure.
I just realized I skipped this question. Number 5.
Well, I think we didn't get to finish it last night. I think we briefly talked about it.
Yeah, we briefly talked about it, but
so again, p prime of t is easy. That's just 0.33 because that's
number 5. Sorry.
Oh, sorry, I meant number 4.
Yeah.
Okay. Oh, yeah, we never even touched this one. Okay.
Yeah, this one started to get really confusing.
Okay, I thought you could say it's only 6, 7, but yeah, okay. How fast is it growing? So you want the derivative. So you want p prime 20, p prime 30, and p prime 40. Now, you could do this by hand. It's just a little complicated to do by hand. So I'm not sure if I'm gonna. I mean, if you were to do it by hand, it would look like this. But we're gonna do it in the calculator regardless because it's just.
Yeah, and I want to learn the calculator version because I did.
I don't know if
we
your
did
teacher wants you to do this. I mean, I'm not sure your teacher wants you to show the work here.
because we did the on with the other one person. We did the sino. I forget what it's called.
You could do the chain rule here.
Oh, you can. Okay.
Yeah. So it's 150 times all the entire denominator. Geez, you have all these dealing right now. Wow, you're teaching really well. Yeah. So anyway, so you have that. So the bottom just gets risen to -1 power. Then we do the derivative.
Wait, is that 1 plus 15,000?
Yeah, I'm just copying what I saw in the denominator. That's all.
Okay.
I just recopied. I didn't do anything special. I just raised it to -1 power.
Yeah, because instead of having all of the.
Then
Yeah,
what I do is I move the -1 to the front.
P prime equals. Plus 15. Is that e to the negative 0.35? Oh, it's always been negative.
Yeah.
Oops. Negative. And then times negative 0.35?
Right.
All right, cool.
Yeah, so it just gets really messy. If you clean it up, it'll be -150 times 15,000 times E times -0.35 all over oh, so I should be raised to the second power. Yeah, that's just crazy. That's really.
And so you said you used the chain rule for this?
Yeah, and then you plug in 20, 30, and 40, but it's just not. I don't think that's really terribly efficient, to be honest with you. I wouldn't do it this way. So here's what we're gonna do. I mean, I'm not sure your teacher wants you to do that derivative by hand like that, but so you got all this?
Yeah, I did. Yeah.
Okay. Here's what we're really gonna do. We're just gonna use the calculator. It's just smarter that way, you know.
And I know like a question very similar to this is going to be on that quiz. I know it, sadly.
Okay. So, oh, let me undo. Okay. Yeah, so what I'm going to do is I'm going to go alpha window option 3 and deriv dx, and then type in that equation. Now what you could do is you hit alpha y equals, and you can call it, let me clear, it's hard to see what's going on. Hold on, let me
Yeah.
put eraser here. Okay. So let me clear right. So again, alpha window, option 3, end deriv, or math 8. Oh crap, hold on. Alpha window, third time's a charm. Here we go. And then put an x. And then because I want to type in a fraction, you could do a lot of parentheses and division, but if you hit alpha y equals, the first option is the fraction option, which is really lovely. And then you do 150 up top. And then down below, I do 1 plus 15,000. Second, ln. You don't need to do it times. Negative 0.35. X. And then we're going to type in 20. So I don't need to do -1 power because I already put it as the bottom as a fraction. Because really, it's, what's really happening is a division process, 150 over all that chunk, Now,
Yeah.
if I hit enter. What the, damn it. Shit, sorry.
No worries.
No, when I hit second enter, it calls out the previous.
So wait,
operation. Let me do
can we do that again? So
yeah,
how do you
let's do it
get
again.
that?
Okay. So again, alpha window, option 3.
Alpha window, option
Option
3.
3.
Okay.
Then
Yep.
you go put x here. Then you hit alpha y equals. Hit enter.
And then alpha y equals, and then which function?
And then you just type in 150.
Oh wait. So wait. After that, after putting the x, and then now I do alpha, and then you say
y equals, right, and pick the first option.
First option. Thank you. All right. And why was the first option for that?
Fraction.
Oh, okay.
Yeah, then put 15,000. 150 in the numerator. 1 plus 15,000.
Then e.
ln e negative 0.35x. And then you put x equals 20.
Negative 0.35x.
If you hit second enter, change it to x equals 30. Then second enter.
Wait, how are you doing that? Second what?
Enter.
Second enter. Oh, okay.
Yeah, and then yeah, that's what we do. And so those are all the answers for parts A, B, and C.
Cool.
Yeah, because then you just replace the x, the x equals part with 20, 30, 40.
Yeah. Yeah.
So yeah, that covers that.
Cool.
And then what kind of derivatives you said you want to work on?
Can I work on?
Like from one of the other homeworks?
Yeah. So like product rule and product quotient.
Oh, let's work through my test because I just wrote a test for my students. So let's do that.
Okay, sweet. Yeah, I'm here. Yeah.
Here we go.
Because I'm gonna try to retake it sometime.
Have you guys done derivative trig functions or not yet?
No, not yet.
Okay, then let me just write some new ones in. Let me make that.
And also now we're starting to get into like the business aspect of
Okay.
calculus too. Or
My guess is you probably work on marginal cost
yeah, she started talking about that this week.
and revenue. Yeah. Come on.
Yeah.
Hold on a sec.
So I know C is the quotient rule. Then
Yeah. Okay, so we'll start with part A. Part A is kind of a trick question. Don't get intimidated by it.
so would we do x and then in parentheses x over and then in parentheses e minus one and then out of parentheses -1?
What do you mean?
So it would be x. So y equals x x and then in.
All you're really doing is you move the. It's just a power rule. Because your numerator is just a constant.
Okay.
So you just move the. Sorry, your exponent is just a constant. So you just move the exponent to the front.
Mhm.
And then times x, and just drop your exponent by 1. That's it.
So y prime equals. Oops.
So that's all you're doing. It's no different like if x to the 5th power. Move 5 to the front, drop the exponent by 1. That's all. It just happens that you have root e minus 1 is just a number. Move it to the front.
I thought we were supposed to take out root though for derivative.
No. That's if you have x inside of it. We don't have an x inside of this.
Oh,
It's a
okay.
constant. It's not a variable.
Oh, okay. Got it. Thank you.
Yeah, that's all. So that's why I made this worth 2 points because yes, it's not that much work to show there. So that's all.
Yeah.
So now here we're gonna have to do the product rule.
Uh-huh.
So
We know that's a product rule because it's multiplying by each other, right?
yeah, exactly. So you got to take derivative x8, which is 8x7 times natural log of x plus x8 times derivative natural log of x, which is 1 over x.
That would be the answer, right? Yeah. Wait, no, it wouldn't be the answer because we need to do the whole.
So we're done. I just simplified it. That's all.
Oh, okay. But don't we have to do f of prime of x times g of x plus f of x times g
But
prime of x?
I already did that.
Oh. Oh, I see.
I already
Got
took care
it.
of that.
I just realized that. Okay. Yeah. Okay, got it. Yeah. And then quotient rule, I think I understand this one. X plus x to the third. Oh, but it's rooted. Do I deal with the root first?
Okay, so here, remember it's quotient rule.
So right. So I would. So f is 10x minus x to the third.
So then we do this one, y prime, we know it's f prime g minus fg prime over g squared.
Wait, what?
Over g squared.
Oh, yeah. That's right. Yeah. You're right. Yeah.
So you get to
And
your
then-
f.
So which is 10x minus x to the third. G of prime. Would G of prime be in parentheses x plus 1 and then out of parentheses minus 1?
Hold on. Repeat that one more time.
Because it's a root x plus 1 when we have to take out the root when we're
Yeah, so that's
deriving.
x to the 1/2 power.
X to what?
To the 1/2 power. So let's back up a little bit. Hold on. We need a little more space. We'll see over here. So we have 10x.
Right.
Okay. So your f is like 10.
But f would be 10x minus x to the third.
And what's the derivative of that?
The derivative of that is 10, just 10 minus 3x to the second.
Right. Okay. Then here, g is root x plus 1, which is the same thing as saying x plus 1 raised to the 1/2 power. So when you do the derivative of that,
Oh, it's the half. Oh, I keep switching that up. Yeah.
so now you have to piece it all together because y prime is going to be f prime g plus
Right.
fg prime over g squared.
10x minus x to, oh, no, it'll be f prime. So it'd be 10x plus 10. It would be plus, right? Plus, so f prime of g plus.
No, minus.
Oh, it's minus. Okay.
F, which is 10x times g prime, which is all that junk. I'll just put g prime all over g squared.
Cool.
And I wouldn't bother simplifying it, but
No. Yeah.
yeah. So, yeah, that's what we do.
Awesome. I understand it. I just don't know how I did. Before the test, I felt very confident. When I got into the test, I was not confident at all. And a few of them, I felt like I didn't know where to put the chain rule at all.
Mm-hmm.
I thought everything was the quotient and product rule. So yeah, so hopefully I did okay. This week I'm definitely going to retake it because we're allowed to, which is nice. So yeah.
Good.
Thank you again so much, Gus. You're a huge help.
And did you want to just reach out to me when you need to meet again, or?
Yeah, and I promise I'll email you.
Yeah, you're good at doing that. Yeah. So what I'll do
again,
is
sorry about that.
No, so let me close the session and then download. And then I'll upload to YouTube. So probably next 30 minutes you'll get the YouTube link.
Perfect. Thank you so much, Gus.
All right, sounds good.
See ya.
Mm-hmm.